Consider this physical problem. A particle at an initial location was released with an initial momentum. Provided that we know all the obstacles it has to go through, what is the time for the particle to arrive at a particular location? As simple the problem is, the solution is just as straightforward. For arbitrary obstacles, Hamiltonian mechanics provides us this general expression. On the other hand, when we shrink our working space in the quantum realm, things are not as easy, as time is not equally treated like position or momentum in standard quantum mechanics. But by performing some math, we can overcome this issue. In familiar notation of quantum mechanics, the time of arrival of the particle can be represented by this operator. Phi here represents the wave function of the particle, and the kernel of this integral defines the time of arrival operator. But how do we find the time kernel? One way to solve this is via the framework of supraquantization. What's special with supraquantization is that it is an autonomous first principle theory of quantum mechanics. By invoking postulates about the universe, quantum theory, and times of arrival, the time kernel is found to be expressed as a product involving some unknown factor. This time kernel factor is retrieved by solving this differential equation along with its boundary conditions. In this study, we applied the method of successive approximations in which we found the solution can be expressed in closed form. With this, we have been able to finally investigate the dynamics of a supraquantized time of arrival operator. For assigned potential, we have observed that the wave function collapses to the appropriate eigenstate of the operator, such that the particle arrives at its destination in the intended time equal to the eigenvalue of the operator. Significant as these results may be, the solution we found has limitations. In particular, it is only valid for potentials that satisfy this particular separability condition. More specifically, they are only valid for potentials of this form. So the search is still on to find the closed form solutions of other classes of potentials.